Ever pondered over the inner workings of logistic regression? It might seem like a labyrinth of mathematical formulas and concepts, but fear not, for today we unravel its mysteries. The journey through logistic regression requires us to understand three key concepts: the sigmoid function, the odds ratio, and maximum likelihood estimation, or MLE. First, let's tackle the sigmoid function. It's the heart of logistic regression. Picture a mathematical function that takes any real-valued number and squashes it into a range between 0 and 1. That's the sigmoid function for you. It's a beautiful way of converting numbers into probabilities. For instance, if the function spits out a number close to 1, it signifies a high probability of the event. Conversely, a number close to 0 indicates a low probability. Next, we delve into the realm of odds ratios. Now, what are odds? They are simply the probability of an event happening versus it not happening. For example, if an event has a probability of 0.75, the odds of that event would be 3 to 1. The odds ratio in logistic regression is a way of expressing the odds of an event in terms of the independent variables. It's like saying, for every increase in X, we expect the odds of Y happening to increase or decrease by a certain factor. Now, brace yourself for the final concept: maximum likelihood estimation, or MLE. It's a method that helps us find the parameters of the logistic regression model. Imagine you're a detective and you're trying to find the most likely suspect. MLE does something similar. It finds the parameter values that make the observed data the most probable. It's like saying, given the data we have, what's the most likely set of parameters that could have produced it? In summary, logistic regression isn't as daunting as it seems. At its core, it uses the sigmoid function to convert real numbers into probabilities. It then utilizes the concept of odds ratio to express the odds of an event in terms of the independent variables. Finally, the maximum likelihood estimation method comes into play to find the most likely parameters of the model. It's a fascinating journey of transforming numbers into meaningful insights. So the next time you encounter logistic regression, remember, it's not a maze of incomprehensible concepts. It's a systematic process of understanding probabilities, odds, and making the most out of the data at hand. Knowledge of these concepts not only unravels the mysteries of logistic regression, but also equips you with a powerful tool in the world of data science.